let's look at a website. You're going to be doing a homework involving this website. It's the University of Minnesota Interactive Gallery of Quadric Surfaces. And these are also in the book reading. It's what happens when you have basically any kind of nice quadratic in 3 variables. Must have been it's not anything. We're not using like x times y. Those tend to be a little more complicated. And you look at an equation involving a quadratic and x times y. And it depends very much on whether all of them are squared, like in these 3 examples, or if one of them is not. And also on signs. And so you get various types. And this is a good introduction to that. So here on the home, you want to go ahead and read the instructions about how to manipulate them, clicking and dragging, shift and click, that kind of thing. And this note about domains is important, but I'll just demonstrate a couple of things on that in a minute here. So let's go to, for example, the ellipsoid. That's one of the simplest types. It's a very natural generalization of an ellipse. And so in this picture, first of all, you can click and drag to rotate. And then the blue dots give you cross-sections or traces. And that's very, very good to see this idea of traces, which is an intersection of the surface with a plane parallel to a coordinate plane, to see that in action. And to see it dynamically and how, there we go, to see how those traces can change. They're all ellipses of different sizes in this case. And here, of course, these are ellipses of different sizes, and similarly for if you move this dot. Okay, so that's one fixed equation with different traces, and then down here we have the blue dots are rather different. They are taking A, B, and C and manipulating those and changing the shape of the thing. And so notice that as we change the parameters, these are the parameters A, B, and C in this equation, they change the shape of the thing. This one is very, very similar to what happens with an ellipse in 2 dimensions in terms of what these parameters are going to mean. So it's not too counterintuitive, but I'm changing the wrong one. But you want to play with this to get an idea of how these coefficients change the shape of the object, and then how the traces analyze the object further. Another example, this is one that really doesn't, that is a bit different from what happens in 2 dimensions. We've got an equation where we've got 2 minus signs, and it's all equal to +1. And it turns out those 2 minus signs create a shape that has 2 pieces. It's a hyperboloid of 2 sheets. And we'll go ahead and we'll analyze this a little more carefully. But it's good to play with this and start thinking about how are these equations making this kind of behavior. In particular, like these white curves, this is what happens when I take this equation and I set z to be a constant. Why are there some numbers z where I don't seem to get anything at all? And then suddenly, for some value of z, it reappears as an ellipse, and then for other values of z, it reappears as an ellipse. Can you figure out what those magic values of z are, where something really changes qualitatively? In the other directions, we get these hyperbolas when I set x to be a constant, for example. Why is it that when I set x to be a number, I get a hyperbola? Then similarly here, you can change the parameters, and you can see how the influence of c changes the shape, makes it flatter or more curved. B is going to change the shape as well. A kind of squishing and stretching in the various directions. So you've got a web homework with some explicit questions about this, but you really want to play with, at least take a look at all of these examples to get a feel for this app, because we're going to want to use this a fair amount.